Go ahead and start this recording. Thanks so much for joining us today. I am going to jump right into this broadcast because we have 45 minutes and so much great content to cover. So if anyone misses the first few minutes, we will make a recording available after this. So hi, I'm Torey Penrod-Cambra, one of the co-founders and the Chief Communications Officer here at HighByte. I will also be your moderator for today's panel discussion. And let me go ahead and queue up some housekeeping items first before we jump in. All right, hopefully everyone can see that. Great. Okay, so as I said, this broadcast will be recorded and shared. Give us a day or two to get it out to you, please. And if you see any slides or images that we share in this, we can make it available to you upon request. So just let us know. You can reply to me or info@highbyte.com. And throughout the presentation, please use the Q&A tool to submit any questions for the panelists. I will say that thank you so much to everyone who already submitted questions in advance. We truly designed this presentation around exactly what you wanted to hear and see. So most of your questions will be addressed throughout the presentation as we move through it. And then finally, there's a very brief exit survey at the end of this. If you would just take a moment to answer those two questions, that'd be great. So the reason we're all here, we'll be together for the next 45 minutes, and we're discussing data access, governance, and scalability. What are those requirements? How are they changing? And how can an industrial DataOps solution like HighByte Intelligence Hub fulfill those requirements for industrial companies? So our agenda, we're going to move pretty quickly today. First, we'll start off with some introductions. I'll do a brief introduction of HighByte as a company, and then introduce you formally to John and Aron if you haven't already met them before. And then we'll break the discussion into three sections. So first access, then governance and scale. And each one of those sections will include questions for the panelists and demos from HighByte Intelligence Hub from the latest release, which was version 3.1. And then finally, if we have some time left over, we'll do a little Q&A with any questions that come up throughout the presentation. So I'm going to go ahead and launch a poll because I want to hear from you too, and it will help frame up this discussion for us a little bit. And that is, how familiar are you with HighByte Intelligence Hub? So you use it regularly, use an occasion, I don't use it, but I'm familiar with it, I've heard about it, or I'm brand new to HighByte in the Intelligence Hub and just here to learn today. So I will keep this open for the next. Okay, responses are starting to come in, next 20, 30 seconds maybe. Great. Good, good. It's a really nice mix. Okay, I'm going to go ahead and close the poll, and you should be able to see the results shortly. If you head over to the polls tab, you can see the results there. So a nice mix. A lot of you are very new to HighByte and to the Intelligence Hub, so that's helpful to know, and kind of cues up what I was about to share next, which is an overview of HighByte. So who are we? We are an industrial software company, and we're on a mission to be the global standard for industrial data ops or data operations for manufacturers and other industrial companies. And we developed HighByte Intelligence Hub, founded the company in 2018. And the Intelligence Hub is kind of shifting the paradigm of how industrial companies are thinking about their data architecture and their data integrations. And so moving away from that, Purdue model and thinking more of their integrations as a hub and spoke approach. While we are recently founded, the founding team has a lot of experience in industrial software. I think it's no secret. Many of us came from Kepware Technologies. And since launching the Intelligence Hub in 2020, we've seen a lot of growth over the past few years, now in more than 100 deployments, 18 countries, and 15 different vertical markets, including life sciences, food and bev, machine manufacturing. So a really widespread of companies that we're now working with and learning from as well. And I'll mention too, that's all kind of made possible by a network of companies that we work with globally, including our distributors, system integrators, and technology partners, many of whom are live with us today. And so HighByte was really founded because we were looking at the market and saying, okay, there are definitely many use cases that rely on industrial data that are growing exponentially, but there seemed to be a problem, and that was that the underlying infrastructure really didn't exist to support that. And as more users and more systems outside of process control and manufacturing wanted access to this industrial data, sort of the pipes, the infrastructure to get that data there in a format that was usable just didn't exist. And so that's why I have John and Aron with me here today. And as I said, we're going to jump in on data access, governance, and scale. So let me introduce you to the panelists. John is Chief Product Officer of HighByte, focused on product management, customer, and partner success. He spent his 25-year career both delivering software to manufacturers and working for manufacturing in operations roles. And Aron Semle is our Chief Technology Officer, focused on guiding the company's technology and product strategy through product development, technical evangelism, and supporting customer success as well. And Aron has more than 15 years of experience in industrial technology, and I'm so happy to have them both here with me today. And so, no further ado, I'm going to jump into the first section, which is data access. And so, the question we posed here is, why is data accessibility important in industrial environments, and how are these requirements changing? So, to kick us off, John, I'm going to send this question your way.
Great, thanks, Torey, and welcome everyone. Nice to speak with you, and we look forward to your questions and feedback. Yeah, so what we're seeing in talking with our customers and companies in manufacturing is there are vast quantities of data that's locked up in their OT systems, whether it's from sensors to PLCs to MES to historian to lots of different databases and data systems on-prem. There's lots of information out there, and the challenge is, how do we get access to it? And ironically, as companies add new technologies, like they're putting out new sensors, or they're putting out AGVs, automated guided vehicles, or they're focused on environmental health and safety, and they're putting out new data sources, data sensors in their flue stacks or whatnot, it just adds more data silos. And so they're finding that, how do we break down these data silos? At the same time, they're seeing broad desire to get access to industrial data within their enterprise. So, for many years, we've provided enough information for operators to operate the line. But the idea now is, how do we make those operators more bought into the information by maybe we tell them who the customer is of the product, or how do we get them information so they can manage multiple machines at once? How do we get information to the manufacturing supervisors? We're also seeing a lot of use cases outside of the typical OT user, so more into the quality team or the maintenance team, or even to vendors and customers. How do we share information with them? And it's all about driving better decision making. So, really, that's where we're seeing accessibility be a challenge, because in the past, all we needed to do is give people access to some systems that were running our automation, and they were good. And now we're seeing a lot more desire for information, as well as people who are outside of our typical controls network and want to use the data across, maybe even across our enterprise. So what that's caused is a change in the way that people are integrating data and integrating systems. For one thing, it's really important that you're able to format the data and move it around. And the first approach that HighByte took in moving data was really to create a data hub. We call it the Intelligence Hub.
Mm-hmm.
And we were able to create point-to-point systems, point-to-point connections to each system that we need to move the data to and from. And that way, instead of having one system being connected to 5, it was only connected to 1. It was connected to the Intelligence Hub, and we were able to move the data from source systems, maybe combine it, do some data engineering on it, and then move it to target systems. And so that was the real concept of the Intelligence Hub. As we started to scale that out and customers started to mature, they said, we'd really like to have our systems be able to subscribe to data. And this was really the advent of us adding the MQTT broker. So in this case, we were able to create a unified namespace within the HighByte Intelligence Hub so that all that data we could push into the UNS, and then people could subscribe to that data and get access to it. So we didn't need to know exactly who needed it. We would just make it available. The latest maturity that we're seeing is really, and we developed some new functionality in version 3.1 for this, is where people and systems need to be able to make ad hoc requests for data. So how do we expose the data that the Intelligence Hub has access to, but expose it ad hoc so that other systems can make use of it? And so with version 3.1, we released our REST data server, which allows us to expose all of our OT data connections. So whether it's connections to sensors and PLCs, to SCADA systems, MES, the ERP systems, and other databases, expose all of those over a single REST API that any application can get access to. Now, some of the common use cases for this are maybe you want the MES system to be able to request order information from your ERP. So it needs to know what the order number is, but then the ERP system has the details. It can make, the MES system could make that request through this REST data server, pass the order number to the ERP system, and then get the details back. So that's one common use case. Another common use case is a data scientist who's looking to get data sets out of a Pi historian, and they're able to ad hoc request updates to those data sets through this REST API without having to go in and configure the Intelligence Hub. It's just that all that data is now accessible if you have access. Of course, it's secure, right? But if you have access, it's accessible.
And we'll take a look at the REST data server in a little bit today. You brought up, John, one data source that I think is definitely worth talking about more. And in fact, I'll jump to the next question because Philip, hopefully you're on. Thank you for submitting this question. How does HighByte Intelligence Hub compare to Aviva's Pi Asset Framework? And so let's just talk about it. Aron, do you want to field this question?
Yeah, I got this one. I realize it looks like I'm in a locker room. I'm not. This is our side office, so I'm not in my local gym. But yeah, so Asset Framework, if you're not familiar with it, Pi is an historian, stores process data, machine data from OBC, et cetera, really efficiently. And then they added Asset Framework as kind of a modeling layer on top of Pi. So to give Aviva credit or Pi credit, they realized the need for modeling. So it's similar in the sense of a SCADA, where you create a model in your SCADA system for a boiler, and then you kind of reuse that. So it's used for Pi Vision and other things. It's a great tool, and there is overlap in terms of they have models and elements, or what they call elements, what we call instances. The biggest difference is we are not an historian. We're 100% focused on data ops and that modeling layer, and we do a better job. We're much more focused on moving of data between systems, right? So Asset Framework is great inside the Pi environment. There are tools to get Asset Framework data out of Pi that are great too, but we're better at, let's say, connecting to a multitude of systems, not just historians or SQL or et cetera, bringing that data into a data model and moving it to more flexibly to other systems too. But there's certainly overlap. And we have a lot of customers that use Asset Framework and Pi. And I'm going to try to launch my first video, so we'll see how it goes. I got to hit mute. Let me know if you can see that, Torey.
Yep.
So I'll just kind of narrate this video, but essentially if you've done a lot of work to go build out Asset Framework, and I'm showing Pi System Explorer here in a demo where you've got a plant and a line hierarchy you've built out, all of this is mapped to Pi data points that are in the archive, right? So in HighByte today, we've added a lot of features in 3.1 to better integrate with Asset Framework and let you leverage that. So in here, I'm realizing how fast I go through demos as I'm watching myself do it versus do it in person. But what I'm doing here is I'm going and reading that whole plant hierarchy in HighByte. So we can get like the real-time data, the current state of all of those assets in HighByte as a payload. So you can move that around, which means if you've modeled it in Asset Framework, you don't need to remodel it in HighByte, right? You can move the whole thing through, you can mix and match it and whatnot. This feature I'm showing you is new in this release. We can query Asset Framework for the metadata. So not only are we getting the data, but we can get like, hey, this attribute is related to this Pi point. And what we can do there that's really cool is if you've kind of structured your data in Asset Framework, you can point to a part of the Asset Framework tree and say, give me all the Pi points that are underneath this tree. So you can use Asset Framework as a way to organize your data. And then HighByte can come in and say, I'm going to get all the points under this part of the tree. And then I'm going to move that raw data up to Azure Blob or S3 or some other source. As I go through this video, I kind of show you how I'm doing that. So I'm grabbing the point list out of Asset Framework. And what's cool about this is if you then go into Asset Framework and you make a change, add an asset, et cetera, that automatically shows up in your data flow. So you don't have to go back into HighByte and reconfigure it. So that's the cool point. I think since we're short on time, I think these videos will be posted, but the other key feature we added in 3.1 is point changes. So this is showing you how to query the raw points, but we can also do a point change query where we subscribe to data point changes, which means if you're, actually I can speed it up. Here you go. We can get the changes. So you can subscribe in and say, I want new data that shows up. I want data that's changed. I want data that's been deleted. So if you want to get late arriving or change data sets through HighByte and land those up in an S3 bucket or Azure Blob, et cetera, and kind of merge that into your data set in the cloud, you can do that now in HighByte 3.1.
That's awesome. Thanks for sharing, Aaron. I feel like this connection has become so much more sophisticated in the past year.
It has, and we're doing even more to it in 3.2 around pipelines. So hopefully by the time we get done to the next release, you'll see a really cool demo of us moving mass data out of Pi using some of those same techniques, but you'll see it all in one place in the product and pipeline. So we're excited for that.
Awesome. One more question in the access section, and this one I believe came from Sebastian. So thank you so much for contributing this. What specific tools or technologies can you recommend for real-time data retrieval and analysis in a complex industrial environment? Aaron, I'm going to come back to you on this one.
I think this one's me. Yeah. So I think the key here is you want to embrace open standards, right? I think you probably hear that all over the place. So use open standards, and then you want communication patterns that match your need. Okay, what does that mean? In our space right now, it means, hey, MQTT UNS for real-time report by exception data, right? That's clearly gaining momentum. It's easy, it works, it's an open standard. And then on the other side of that, for data that's not report by exception, that's mostly like machine data, state, that kind of information. For more transactional data like you get from MES, ERP, historical data like from Pi we're talking about, that's more transactional. And the standard there today, in my opinion, is REST and HTTP, which isn't new, but it's a way to come in and say, hey, at this point in time, what's the state of this asset? And again, I've got another, I know I've done it once. If I can do it again the second time. So I have a demo of the REST API server that we added, which
let's jump into a new.
We got to mute it. Which is a huge new feature in 3.1, which it really shifts the product, right? Before we would collect data, model data, move data into a UNS, into a database, you name it. Now we have an API on that you can come in and do a read or write request and get the data on demand. Right, so I'll kind of skip ahead, but in this video, what I'm trying to show here is I've built out a UNS. This is cool. I can pause it. That has a conveyor and then pump information. You can kind of see I've a very simple unified namespace. This is all driven by MQTT. This is all the stuff we've already done. Well, what if this stuff is I didn't show here, but this is coming from SQL, right? The state of the pumps in this example, which is okay, but it's a little awkward to publish SQL data on some time interval or data change up to the UNS. You can do it and there's use cases where that's perfectly valid, but there's a lot of other use cases where it's transactional, right? At a certain point in time, maybe I get an update through the UNS. I want to reach into the SQL table and say, hey, give me the status of this work order. So what we've done in version 3.1 is this is a SQL input I'm creating that will go out and request a particular pump based on serial number. And what you can do now is through the REST API, and this is just me showing the return of that. So now in the REST API, which you can enable in our settings, you can query this input directly. And this is what I'm showing. This I'm showing as a Swagger API. So you can click a link in the product that brings up the Swagger API, which totally documents our full interface, which is really cool. You can do reads of instances and inputs, and you can do writes to outputs. So this is me showing using the Swagger API. I'm querying that SQL input. I'm querying that SQL single pump that I created, and I'm going to pass it the identifier, the serial number for the pump I'm actually interested in. I think I actually jump back out into the UNS and I copy a different one. And then when I make this request, it's going through HighByte down to the SQL input, making the request and returning the result back as JSON, just as I would see it in the UNS, but it's transactional, right? And I get that full payload. So it's a whole different communication pattern, right? Report by exception, UNS, fantastic. But if I need to drive more transactional stuff like query historical data or query an MES state, the REST interface gives you that ability to do it. The other cool one I show in this demo is the ability to write. We probably don't have total time, but basically I create an OPC UA output, right, that I can then use the same interface, the REST interface, to do a write, which you can see down here. I'm writing the on state of one of the conveyors. We translate that from REST into OPC UA, write it out to the PLC, and then it comes back up through the UNS and shows that on-off state in the UNS. So you can dynamically control, and writes are another thing, right? Can you do writes through a UNS? Yeah. Is it weird? Yeah, it's weird, right? It's kind of janky. So REST, it's more transactional. It's a much better interface to do that cleanly. And I think when I end this video, the only thing we want to do over time is right now, we want to harmonize the route. So if you build out a UNS that's ISA 95 structured, and you're getting the data updates, MQTT on like Portland, Maine, R&D, line 3, you should be able to come into the product and read that same base URL and get the same result. And we're not quite there yet, but that's kind of where we're going. We're harmonizing REST and the UNS to make that really simple for customers.
That's awesome. Thanks for sharing, Aron. Okay, I'm gonna set data access aside for a little bit. And before we jump into governance, I'm gonna launch another poll. And I'll preface this by saying we've been thinking a lot about DevOps processes, how DataOps can incorporate into that, and CI/CD processes. So my question for the attendees today is, are you using DevOps processes within your industrial systems? Options are yeah, in an advanced capacity, yes, but not frequently. Maybe you're considering it, or no, not at all. I'll give you all some time to contemplate this. I see some other chats and QA coming in as well. Some of those I will respond to, and then others maybe we'll have time at the end to address live. Okay, some more results are coming in. Good. A big mix again. Okay, I'm going to go ahead and close this poll so you can view the results. So the majority of you are considering it at about 47% of respondents, and about 30% have responded no, not at all. Okay, so good. So let's talk about, let's go ahead and move into the governance section of this, and I'll pop back up my screen. And we'll jump right into the first question. And this is one we crafted internally that we wanted to address today. I think we shared this in the abstract for the webinar. And that is, which governance practices and technologies best prepare industrial data for enterprise-wide use? And John, I'm going to come back to you. I don't mean to get lonely over there. You field this question for us?
Thanks, Torey. Yeah. So I think we may have kind of shown our hand a little bit with this one. What we're seeing is companies, especially companies that are, as people are deploying more and more of this technology, they're broadening out. It's, it started out with maybe one person in a factory. It moved into the entire site. Now it's moving across the enterprise. And as they're moving data, say, to the cloud, or they're trying to run these common use cases across the enterprise, data governance is becoming really important. And in terms of approaches, what we're seeing is DevOps and people using common IT systems and DevOps processes as a way of managing their OT systems. And so what we're seeing is people wanting to use applications like Git and applications like Splunk to manage systems, or Datadog to manage, log files and things like that. But we're seeing it both in, let me manage the project, but also let me manage down to the individual use cases because I'm rolling out these individual use cases. We're also seeing people using third-party applications. So like a digital twin application or an IoT platform that's defining a model of data that they want to consume, and then we need to have some way of pulling that data, that structure down into HighByte so that we can deliver them the data. So the practices that we're seeing are those DevOps processes or standard models created by third-party systems. And so HighByte actually in our 3.1 release has added a number of tools around that so that we can easily export and import partial projects. We can export and import models and instances right into the software from third parties so that we can really make that whole process really seamless and allow people to effectively manage their systems.
That's great. Thank you, John. And I think that actually cues up the next question really well too. This one came from Sebastian. How does HighByte ensure robust data governance? How does your approach align with emerging regulation standards? John, you mentioned ingesting models and import-export. So I'd love to turn this over to Aron, who can maybe show some of what this would actually look like inside of HighByte Intelligence Hub. Answer this question too.
Oh, there's a delay. Unmute myself, and then yeah. So I mean, data governance is the core of what we do, right? I mean, it's really kind of the foundation of HighByte is the idea that manufacturing data is highly unstructured. If we're going to get that to the cloud and other systems, we need to structure that. We need to do that at scale. We do a lot more than that, but like at the core of it, right? That's the problem we're solving. And then even in individual companies, as you go across factories, different facilities, it's totally different. So that difference needs to be abstracted if you're going to use the data. So super important. So kind of the governance side, what we see in customers is they start out with, okay, I'm gonna model my data in a particular factory for a particular use case, and that's the core piece. I'd say that the folks that are most advanced in this are use case driven modeling, not trying to model the whole factory, not trying to get all their data to the cloud. Use case driven approaches. So they'll create a use case, simple model, get that moving up to the cloud, again, an S3 or Blob or IoT Core or whatever product, and get that working and see some value. And then they go to deploy it to the next factory. So then on the governance side, the question of scale comes up, and that's really the question of governance. Like, okay, I did it here and it worked, it helped me, but now I need to do this across my enterprise, and how do I lock that down? And I would say most customers still, people can get tied up there where they get super focused on that problem and they haven't seen the value from the individual factory or a few factories yet. So you can kind of get out in front of this one, but it's a good question to ask. So my answer to that is, in my opinion, what I think will happen in the industry is that those schemas, those models, that governance layer, it's really going to be defined by some central system, and there could be multiple systems, right? And I couldn't pick the winner today, but I think key to it is, I'm going to have this kind of repository of my model definitions. This is a quick video, so let me pause it. And really, in terms of deploying that in DataOps, I'm going to use existing CI/CD tools. So I'm not going to go reinvent the wheel and create some like custom protocol or design. I'm really going to say, as a really simple example, right? My model definitions are in a GitHub repository that's managed by my DataOps team. If I want to make changes to those models, there's a standard way to do that through it's change requests and it's PRs, reviews, right? There's a process by which that happens. And then when those models change, I have an automated way to take those models and bring them down to the edge. And what is that automated way? That's existing CI/CD tool sets that we have today. So if you're using Docker or Kubernetes, you can bake, files in, or you can use APIs. What does that mean for HighByte? For HighByte, it means we just need to be really flexible in how we ingest data models and formats and who we get those from. So what's briefly shown in this video, a really cool feature that goes beyond just governance in HighByte in 3.1 is under this project feature, we can now import and export parts of the project, which means that could be connections, that could be inputs, outputs, models and instances, etc. But particular to this conversation, it would be models, right? So I can come in here and hit export based on use case or based on selecting individual fields, and I can get that data out in a JSON format. Now that's HighByte's JSON format of how we represent models. And then I could put that in the GitHub repository and manage that. Where we're going, what we also have is the ability to ingest models in other formats. So in the product today is like DTDL, which is a Microsoft format, and a few others. So the idea is that you're probably going to manage this in another tool or in an environment, and then you need to just be able to quickly get this into HighByte. And everything I'm showing here with the import export is also available via our REST API, right? So you, in a CI/CD process, you could deploy HighByte, send down the model definitions, spin it up, take it down, you name it. So I think for us, it's the flexibility to hook into the process that you want to use to govern those model definitions.
That's great. Thank you for sharing, Aron. It's come a long way. I feel like we had a major release of 3.0 and thought 3.1 was going to be minor, and then it turned into so much more. So thank you for peeling that back a little bit and let us see that in action. That's great. One more question in the governance section before we move on. So let me just pop back up my content again. Last one in here. So this question came in from Francisco. Thank you so much. I think the real core of what he's getting at here is how critical is this data structure piece for industrial companies trying to manage all of this IoT data, and which industries are leading the adoption? And so for that, I'll turn it over to you, John.
Yeah, thanks, Torey. We see it as absolutely critical. We totally see and hear from everyone about the explosion of data. Not only is there an explosion of data, but there's an explosion of users of the data. And what we're seeing is that IT teams and OT teams are being stretched to their limits to try and solve the problem with their existing approaches. And what they're realizing is they really need to take a new approach. Of course, DataOps is that new approach. And really it ties together the concepts that we're talking about today, the concepts of data governance, the concepts of high scale data contextualization and integration, and really pulling all those together into a disciplined approach and a single system to do that, instead of trying to do a little bit in one system, a little bit in another system, and then move data around. And traditionally people have just tried to script their way through any data connections and manipulations, and it just doesn't scale. So I think that's how people are approaching it, and it's absolutely imperative that they do it. In terms of industries, we don't see any one industry as leading this charge. We're seeing interest across automotive, industrial products, food and beverage, pharmaceutical, pulp and paper, metals. So it's not even the ones that you typically think of as the most advanced or the ones with the most technology. Really broad-based adoption across discrete, batch, and process industries. What we're seeing though is it's definitely, it's not everyone. there are early adopter companies and there are late adopter companies, and some companies really pride themselves on being early adopters, thinking ahead, thought leaders. Those are the companies that are experiencing this. And it's funny because the first proof of concept didn't necessarily need this, but the companies that did the first proof of concept 3 and 5 years ago are recognizing none of those scaled. How do we go back and rethink it? And they're the ones that are adopting data ops at scale. So it's not so much about which industry they're in, but more about, are they thought leaders? Are they progressive in their thought process versus do they tend to be laggards?
John, I don't know if you intended to, but you just perfectly moved us out of governance and into scale, which is the final section that we wanted to talk about. So I'm just going to let you kind of keep going on this because I think you're starting to go there anyway. We're talking about the companies that were leading and industries leading. What about those that are struggling? Like what have been or what are the biggest barriers to developing a scalable architecture? What's held people back?
You know, it's been interesting to watch companies. A lot of companies start out and they identify some use cases and they want to do a proof of concept of it. And they hand it off to a team and say, this is your project, do this as quickly, as efficiently, as cost effectively as possible to prove this out. And they go and they do that. And then they look at that proof of concept. What did it cost? What is it? And then how do we scale that out across our factory? So maybe it was monitor one motor. Now we need to monitor 50 or 500 motors within a facility. Then they want to scale it out across the sites. And when they started to look at that, or they did the first handful of scale outs, they realized that the costs scaled linearly. So it didn't. There were no volumes of scale and or economies of scale. So, you know, they really struggled with that. And what people are finding now is it takes a different architecture to solve an enterprise deployment or even a site broad high scale deployment than it did for that POC. And that different architecture is based in industrial data ops. And it's really about integrating these systems effectively and being able to really abstract, have an abstraction layer that allows you to easily move and manipulate data, leveraging model-based standardization, leveraging low-code, no-code solutions. And most importantly, when you're doing like 1 model to 50 models, it's doing things like templatizing them and being able to reuse that, which really makes it easy to scale out across your site.
Thanks, John. I'm gonna switch this up a little bit. And the next question, maybe a little bit more technical. Aron, maybe you can even show another demo here. And this question is also around scale. What about use cases? So can we share some behind the scenes look at HighByte Intelligence Hub and what use cases it's solving for companies that, you know, have multi-plant facilities, global organizations?
Yeah, certainly. Let me pull up. John, I need the videos. I can't. You can. I need the crutch, right? Yeah, so a really example, when we think about scale, the first thing you want to do is simplify, minimize configuration and just simplify your design, right? And one of the things we have in HighByte that does that, John had mentioned it, is templating. So we've always had templating. So if you have, you know, 100, let's just keep using boilers. If you have 100 boilers in the factory and those are all in an OPCOA server and they differ by a boiler ID, you shouldn't have to create 100 artifacts in HighByte or your DataOps platform to read all those in. So we have the ability to templatize both inputs and instances so you can provide it the range of IDs and then it can go and query all of those assets. What's different in 3.1 is we added the ability to templatize flows. And what this becomes really useful for is like the use case where I'm monitoring multiple machines and I'm looking at a machine state, right? And I want to send data to the UNS when the machine state changes. So what I'm showing here is the way you're doing this in a flow. So I have machines with IDs in this really simple example that range from 1 to 4, and I'm passing that into the instance. So this is really behind the scenes, like creating 4 flows for you through a single configuration. So it's really simplifying your architecture. And then I set up I'm looking at the state to say, hey, when the state changes, send it up. So it really enables those like simple use cases of I want to monitor all these machines and I want to trigger off a state change. You can do that in flows now, single piece of configuration. In this case, I'm publishing data for 4 assets, all coming from the same OPC server. The other really cool thing we added for scale for a customer in 3.1, which is just generically available now and all templating, is you can actually pull those template parameters from a third-party connection, right? So I can have those template parameters stored in a database, in a CSV file, and HighByte will pull those in and then go virtually create the 10 or 100 or however many flows or instances and pull that in. I think if I skip ahead a little bit, I should have written down the time chunks, but this is an example of I set up a CSV file with the IDs in there, and then I continue to run the flow. And really the key to scale is any kind of, when you're designing DataOps, what you really want to think about is folks start with, well, I want to get all my tag data into the cloud. We'll help you do that, but I'm not really excited about it, right? Because like that's not really DataOps. Or, hey, I want to model the entire factory, or I want to just do asset-based modeling. Again, we'll help you do it, but what we really find is it's use case-based modeling. And the problem you want to solve is not the scale problem of I want to get all my tags to the cloud, or I want to perfectly model my entire factory. The problem you want to be focused on is, okay, I want to add n+1 after I have this set up, and I want the cost of that to be near 0. In terms of bringing that back to this example, the n+1 is going into a CSV file and adding a row, right, a column, and then boom, that new asset shows up in your UNS. That's the kind of stuff you want to focus. If you focus on that problem, reducing the cost of adding new stuff or making changes, then you have scale.
Perfect.
Nice.
I have no
I'm
more
gonna...
videos. I'm tapped out on videos.
No more videos. We like the videos.
I'm gonna come back in here. So, Aron, you just gave some great advice. John, I'm going to come back to you. Agree or disagree with Aron? What do you have for us for top 3 tips? And before you answer that, I just want to say thank you to Ross for submitting this question. So, John, do you have 3 tips? Anything outside of also what Aron just shared?
Yeah, I think what I would say is if data is critical to your success, if you've recognized that what's holding back your digital transformation is the data, and delivering the data in a usable way at scale across your enterprise, then you really should start to think about that as you need solutions designed for that, and you need discipline designed for that. And that's really where DataOps stands. So you need to focus and think about and start looking into DataOps and a specific solution for it, instead of trying to piece together and cobble together some custom things and some applications that you already have that might be able to do a little bit of it, but not really designed for it. So, the first thing we would recommend is have a solution that is focused 100% on DataOps and on moving contextualized data across your enterprise. The next tip I would say is leverage open protocols and open standards. This makes it really easy to integrate with systems. Open standards and open protocols are being used much more than they were 10, 20 years ago. And really, if you focus on leveraging them, then it just makes everything much more plug and play and much more workable. And the third thing I would say is start with your business problems that you're trying to solve. Don't, as Aron said, don't just try to move all the data into the cloud and then we'll figure it out later. Start with your business problems. Are you solving for predictive asset maintenance? Are you solving for first run yield? Are you solving for quality? Are you solving for environmental logging? Identify some of your key business problems, start with that, and then use those as use cases to then grow your data intelligence and your adoption of DataOps solutions.
Perfect. So, John, what I heard you say is 1, implement a DataOps abstraction layer.
Yes.
2, leverage open protocols and open approaches to integration. And 3, start with the end.
You got it. You got it.
Nice. Okay, well, we have 1 minute left, and we have one question left. Thank you, Caleb, for submitting this. I think we've talked a lot about data ops today, so hopefully that is more clear, that intersection of people, process, and technology to deliver the right data to the right people at the right time. But where's it going in the future? So I'll open that up, and then if anyone would like to stay on, the 3 of us are available to start tackling some of the questions that have been added to the chat and QA throughout the presentation, and we can go up to noon Eastern time. So anyone is welcome to stay as we answer some of these. But last comments, guys. Where's this headed?
I can jump in. Maybe Aron, you can pick up where I drop off. But I think the growth of data is increasing. That came up in a couple of questions ago. So if you think out, a few years, we've got 10 or even 100x the amount of data that we're collecting, because a lot of the data that's actually being created today is not being used, and it's not being even pushed through and landing in our system. So there is massive volumes of data. And as you start to think about the systems and what you're doing, and as we think about data ops, it's all about that scale. And what does that scale mean for the systems, for how you configure them, for how you maintain them, for providing agility to your business, as well as how do you secure all that data? And those are the questions I believe that really drive us to think broader, think deeper. We have to solve the data problems of today, but we have to be thinking about the data problems of tomorrow, how we can build a fabric of data solutions across the enterprise, how we can leverage AI or other tools to really rethink and re-architect systems, how other systems will change as you can now effectively and efficiently move data across very easily. And one of the things that I often think about is our cell phones, and how that's become, that used to be one object, one app. Now it's potentially hundreds of apps on there that are very targeted. And how will that model impact industrial technology? So those are just some of the things that I always think about and use to guide me. But I'll open it up to Aron if you have other ideas.
Yeah, when I view the future of data ops, more concretely, it's a team of probably half a dozen people, right, who have a backlog of things, requirements coming from the business, use case driven. They have a suite of technologies, data ops technologies, HighByte hopefully being one of those, edge complete computing platforms using Docker and Kubernetes, but they're specialized in, okay, want to enable this use case. We're going to create the data governance model. We're going to push that to the edge. We're going to work with folks in the factory as lightly as we can to get the data that we need. And then we're going to rapidly kind of iterate over that and find the use cases that drive value to the business. And that's people, that's technology, that's process, right? And I think that kind of exists today in some of our customer bases. I don't think they would think of themselves like that. And then, but that's kind of where I see it going. The other piece I see is part of data ops is moving cloud technology. I have to be careful when I say this, down to the edge, right? So as it kind of infiltrates that, it's almost, I start to think of it as like an edge data lake. So that data ops piece, that piece that's running at the edge, becomes more capable, starts to actually feed systems in the factory, I think, over time, again, using open standards and everything we're talking about. But I think it bleeds down over time as well.
While we're talking about the future, so again, everyone's welcome to stay on for the next 10 or so minutes while we go through some of these questions. There's some roadmap questions that came up in the chat. So as much as you can or able to share, Aron, I think the first question is around, do we plan to incorporate an MQTT Explorer type application into the Intelligence Hub so that users don't have to use different tools for testing? I'll start there and then move to the next question around protocol support.
Yeah, someone's on the inside. Yes. The quick answer is yes. So part of our 3.0 development in the broker was trying to provide what I call UNS out of the box. So what are all the components you need to kind of build a UNS? We're headed in that direction. The one thing we're missing key right now is a client, right? I'm still don't like bootstrapping and sending links to clients or MQTT clients to folks. So we will have a capability in the product to act like a client and view the namespace that you're building. So you can do it all. Again, not trying to stick you with our solution completely, but we want to give you all the tools so out of the box you can get up and going.
Nice. Okay. Next question is around protocol support. This definitely comes up sometimes. Do you plan to include more protocols to access real-time data? Obviously, we currently support OPC-UA, Modbus, and QTT. What would there ever be plans in the future to provide support for something like an OPC server within HighByte Intelligence Hub?
Oh, for us to be an OPC server?
Yeah, I think that's what
never say never again.
It
doesn't get me super excited, but there's MES systems that only talk OPC still, right? So we have had the requirement a few times. It hasn't surfaced enough that we do it right away. But as a server interface, if we did it again, we'd not be trying to replace HMI to PLC communication. That's not where we're at. But there's certain cases where you need that kind of capability. And then in terms of protocols, absolutely open to it. XML has come up recently. We'll probably add XML file ingest. Is that a protocol? No, but it shows you where our industry is.
Yeah.
John, you have anything you want to tack onto that?
I think, as Aron said, we're open to understanding where the industry is going, where the challenges are. When we formed HighByte, we recognized that the data collection was there, the data usage was there, analytics and big data and cloud, but moving the data was where there was a massive gap, and that's really where we focused. A lot of PLCs and devices are all moving towards a number of the open standards. A lot of them are now supporting OPC-UA. Some of them are now supporting MQTT. Some of them even have REST servers on them on board. So we're constantly looking at the market to better understand where the needs are, where we can collect data from, and I guess we'll stop there, Torey.
Good. Okay, I'm going to move over to the Q&A. Majority of folks are still on, so let's work through a couple more questions before we sign off. Next one is, how does HighByte Intelligence Hub interact with Inductive Automation's Ignition SCADA solution, and how can I benefit from combining both solutions? I know we have a number of customers who are using both successfully and find them to be very compatible. Maybe who wants to take this one?
John, it's all you.
Yeah, I mean, the inductive automation team is a great team. Ignition is a great product. Ignition is a SCADA application. Ignition is designed to collect data from PLCs and machinery, ingest that data, and present that data through graphical views, and they do a great job at that. And we have a number of customers who are using both Ignition as well as Intelligence Hub. Intelligence Hub is designed to move data. And when we move data, we oftentimes are standardizing it and structuring it. And many times we're also merging data from different systems together as we're moving it. We can take data from Ignition, we can pull it over OPC, or we can, if it's already been structured in Ignition, we can pull it over Sparkplug B in structures, and then take those structures and either make use of them or do additional contextualization or just move them through. So we don't see it as competitive as much as different systems have different applications. Ignition is a visualization of data tool, and they have a number of drivers as well. And HighByte moves the data, and the two work together, because if you need to move a lot of data out of Ignition and move it up, say, into the cloud, into Snowflake, into S3, into Azure, there's no better solution out there than using HighByte to do that, and it'll deliver exactly what you need where you need it.
Perfect. Okay. Last question. Can we talk a little bit about OPC companion specs and OPC UA information models? How does HighByte Intelligence Hub align with those or plan to align with those?
Yeah, great question. So we all have OPC in our blood, so we're very aware of the OPC information models. That said, they've been around a long time, over 10 years, and we still don't see a lot of support on the device side. It's changing over time, but it's taking a while. So I think in 3.1, John, was it 3.1 or 3.0 that we had the overhaul of our UA client connector? 3.1.
Yep.
Right. And in doing that, we're in a better position to ingest data models. In fact, we have a fix in 3.2 we're working on now to be able to take UDTs out of Siemens and read those into JSON, right? So at the end of 3.2, we'll have the ability to kind of read those structures out as a JSON payload. In terms of actually like interacting with the information model and moving that schema up to other systems, we can do it in the payload level, but that's lossy, right? So like a D word coming out of OPC would be translated into like a number or an int32, for example. So it's not a one-to-one match. But we are thinking about model transformations between systems as systems become more model aware, taking that UA information model and moving it into SQL as a schema, or moving it into AWS Sitewise, which is a model aware tool. So it's definitely on our radar. I think the only thing that prevents us from doing it is just adoption in the market, right? It comes up now and then, but it's not pressing. Like no one's knocking our door down saying you need to support this, but we definitely have our eyes on it. And we think, as it gains adoption, we'll be ready.
I would also add to that a lot of as Aron said, a lot of the companion specs aren't being adopted. But the companion specs are actually just collections of groups within various industries who define kind of the structure or the model of the data that should be collected. So we actually see those as being tremendous starting points for customers who are using Intelligence Hub. And so being able to, with our new functionality around importing and exporting of project files and importing and exporting of models, it would be really nice, and we'll start going down the path of being able to import a companion spec as a model definition, and then being able to, well, you could make changes to it if you want, or you can just use it as it is and use that as your model definition within Intelligence Hub to flow data, from different systems to other systems, and across whatever protocol people want to use that we support. So, the companion specs are interesting, and we see definitely growth in that. That's another source of model definition. We can get model definition from the target system. We can get model definition from companies can just define it within HighByte, or being able to pull those companion specs would be interesting as well.
Yeah, John, that's a great point. And to link back to the asset framework demo, like if you've done the work to go model that in the PLC or OPC server, we're going to do our damnedest to not make you remodel it in HighByte. We'll ingest it and kind of bring that model data in, just like we did with AF would be our goal.
All right, thanks guys. All right, for anyone that submitted a question, either during this session or in advance and we didn't get to it, we will follow up with you. We've made notes to follow up with everyone. So if we didn't get to it today, I'm sorry. We tried to pack a lot into the 45 minutes. So thank you for sharing the last hour with us. I really appreciate everyone's time. Hopefully you found this informative. If you can take 2 seconds to answer the exit survey and let us know how we did, that would be much appreciated. And with that, I'll say thank you, and we'll close off here.
Thanks a lot. Nice talking to everyone. We look forward to meeting you outside of the webinar.